Okay, so we've only used so far the string type of data. We haven't even used numbers. We haven't declared a variable to be a number. We've only used as string, right? We said something something as string, dim something something as string. So now we want to discuss the different types of data types that are available. So if you type in Google data types in Visual Basic, you'll come up with something from Microsoft MSDN, and let's click on that. Data type summary for Visual Basic. So we have the data types here, and we scroll down, and one of them is string, and this is the one that we've been using. Okay? However, there are a number of other ones. Something called a Boolean, something called a byte, something called date, something called decimal, something called double, something called integer, something called long, something called object, s-byte, short, single, there's the one that we've seen already, string, u integer, u long, user defined, and u short. So these are all different data types. So string we've seen already. What does it say about string? Over here. 0 to approximately 2 billion Unicode characters. So string, I guess this is how many characters you could have in a string variable. That's the maximum allowable. Seems like an awful lot. Anyway, that's for string. Let's look at some of the other ones. So here's integer. That should probably be familiar to us. If you declare something as an integer, what does that mean? So it means you can use any of the numbers between minus this number up to positive that same number. Okay? So if the number, this is what? Million, billion. I guess it's 2.1 billion and something, right? So if you wanted like 2.3 billion, you couldn't use an integer. It wouldn't work. You're not allowed to use such a big number. If you've declared a variable as an integer, suppose you said dim x as integer, and then you tried to assign 2.5 billion to x, the computer would complain, the compiler would complain. Okay? So that's an integer. Now they call it a signed variable. That means it can take positive or negative values. And we see it goes from negative 2 point something billion up to positive 2 point something billion. Okay, next one. Another one is called long. So long is much bigger. Okay, this is millions, billions, trillions, and I don't know what comes after trillions. So it's much bigger. So you can, if you want a bigger number, if you're going to need bigger numbers, you might do something like dim x as long, and then you could store much bigger numbers in x. Okay, this is also signed. Okay, so it goes from minus this number to plus that number. Okay, so that's another type. Decimal, here's another type. So you could say dim x as decimal. What does that mean? So decimal means that you can use decimal points in the number. So integer you can't, long you can't. Long are just big integers. Okay, you can't have decimal points if you store something as a long, or if you declare something as a long. Okay, but decimals, you can use decimal points, and it can be basically up to 28 decimal points. Okay, so that's a decimal number. A double is also a decimal point type number, but it can't go as high as a decimal number. So if you don't need as much, you can use, if you don't need as big a number, you can declare something as a double. And by the way, here is the amount of memory when you declare such a variable that it will take up in memory. So even if you don't, even if the number is not that big, still it reserves this much of the memory for the for that variable. Okay, so it reserves 16 bytes for a decimal and 8 bytes for a double. Integer is 4 bytes, long is 8 bytes, and so on. Okay, what else do we have? We have s byte, and that only takes up 1 byte, and those are just the numbers between -128 to +127. Okay, so that's a small set of numbers, and it only takes 1 byte. A short takes 2 bytes, and it goes from -32,000 and something to +32,000 and something. So if you only need numbers in that range, you could say dim x as short. And here's u short as compared to short. Where was short? Here's short, 2 bytes, and u short is also 2 bytes, but look at the difference. This takes on negative values from -32,000 up to +32,000. This does not take on negative values, but it goes up further, more than 32,000. In fact, it's double this number. Okay, so this is called an unsigned short. So it means it can't have a negative sign, whereas a regular short can have a negative sign. But they're both 2 bytes, so the number of elements that they can, the number of numbers that they can realize is the same, but it's just a different set of numbers. Okay, you have long and u long. Same idea. U long will not be negative. Okay, what else? Date. Okay, so date is convenient for when you're trying to store dates in a variable. And one more, car, or car, and that is just single characters. So remember, we've been working with string, which is many characters, but car is just a single character. So it might be any single character, but just one. Here's a little program that gives you an example of each of these types. So short is here, integer is there, long is there, single is there. It looks like a decimal. Double is a bigger decimal, like that. Decimal is like that. Byte, car, string, text. Boolean, we forgot to talk about Boolean. Boolean is just yes or no, or basically just true or false, so it can only take on 2 possible values, only true or false, and date. Okay? Now you might think about how you could do this. Remember, this is a list box, so you might think about how you could do this. Now there's also something called user-defined data types. So one type that we haven't discussed are user-defined data types, and that's where it's not an integer, it's not a string, it's not any of the ones we've seen. It's where the user can define a so-called data type and then declare something to be of that type. So we're not going to go into that, but you can look it up on the internet if you're interested. Okay, something else we have are called constants, and they're kind of variables that can't change their value. Now, it's not exactly a variable because variables are things that change their values. But anyway, the way you define a constant is something like this. So suppose I want to define a constant called pi, I could say constant pi as double. Okay, that's a little different than before. Before we said dim pi as double, but that would mean that it was a variable. But here I want it to be a constant, so I say constant pi as double, and you can also assign the values right there. So I'm assigning the value of pi, to this symbol pi. Okay, and the point of this is that it can't be changed during runtime. During runtime means that when the program is running, for example, I want to assign something new to this variable, like we've seen, that the user can put something in an input box and then that gets assigned to a variable, but that can't happen to pi. So once the program is running, this value cannot be changed. Okay, and that's why it's called a constant. So here's an example of that. So I'd like you to build one of these forms, and then so stop the video now and build one of these forms, and then come back to it, and let's look inside. Okay, there's nothing inside. Let's put something inside. Okay, actually I made a mistake. This is not quite right. It should be that. It's not, you don't spell out the word constant. It's const pi as double equals that. Okay, and then you could do this. Label 1 dot text equals pi, like that, and then you can run it. So try this yourself, like that.